Ariel, how you doing?
I'm doing fantastic. How are you today?
Great,
Jeremiah?
man. Great. Thanks for joining us.
Thank you for having me.
Our guest today is Ariel Manzanares.
Yeah,
My
you're
bad.
good. You're good.
Scisney, author of Majesty and Monotony: Everyday Things with a Cosmic Perspective. It's this wonderful book right here. And Ariel is also the CEO of Everyday Cosmic Perspective and the director of the Robert H. Johnson Planetarium in Lakewood, Colorado. Did I do good on that? Did I miss anything?
That was perfect.
Except for
Thank
butchering
you so
your
much.
name.
Like I said, I mean, that's pretty par for the course, to be honest with you. I'm impressed. I said you could just do Ariel Manzanares-Scisney because that's my handle everywhere. Because the middle part's so complicated. I've got both my parents' last names, and so, yeah, I just go with the second half right now. It's just easier. It's just more efficient, you know.
It's all right. I
Yeah.
tried it.
No, you're good. The kids that I would teach in Taekwondo, they would say marinara, Mr. Marinara.
Marinara?
Yeah. So I think you said massa or something, but so because I didn't hear the manza part.
Right.
I don't think, but like apple, like manzana.
There you go.
Yep. There you go.
So, man, what do you got going on these days?
Right now, working full time on my nonprofit for the Planetarium, and tutoring on the side as well.
Yeah, what's going on with the planetarium? I know that's closed
Yeah.
down right now, but you're in efforts to open that back up.
That's correct. So, just a little bit of background on the building. So, it closed down in 2009, like right around that last big recession, right? Just budget cuts, stuff like that. And it's been shut down ever since, even though the lights still come on at night sometimes. Like if you walk by in the middle of the night, the lights are on. So they're using electricity. But it's been shut down ever since. And since 2019, I've been essentially heading an effort to reopen the building for the community and for future students because that was the place that inspired me to study astrophysics, I think, all the way back when I was, I don't know, probably we were second grade, so however old that is, 8, 9 years old, something like that. So very personal project for me. But we've got a committee right now that's been working with me. Some people have been in and out, but I've had a committee since the very beginning, and we're doing regular meetings. We've been able to get some, we got early on support and then had to take care of some legal things, which we can chat more about for like nonprofit 501c3 stuff, which is taken care of now, thank goodness. But we have donations from that, and we're looking to get our next big purchase is going to be a sort of portable planetarium software that we can take to classrooms and use as a demonstration to show what would be capable inside of a modern digital theater. So that's where we're at right now. Should have the legal stuff taken care of by the end of this month, and then definitely by the time the school year starts around the end of August, September, we're going to be ready to start getting up and running again for more outreach events. So we'll be visiting schools and giving presentations, teaching about the universe, and inspiring kids to want to study space and showing them how the planetarium would be beneficial for our local community.
What is the planetarium going to offer people?
So if you think about it, well, let me back up. When people hear the word planetarium, most people probably think building where you go up and you look at the night sky, right? You look at stars. When really it's just a theater, but instead of a flat screen, it's a hemisphere, right? You take a ball, right? Cut it in half. You have a hemisphere. That's the screen. And you can project whatever you want onto there. So whatever you project onto your television, your laptop, literally anything. So obviously, education would be the primary goal for this facility because it's in a school district. It's owned by the school district. So you can have educational programs ranging not just from space and stuff. And by the way, traditional planetarium, people think, oh, you just go and you see the night sky with the Milky Way and all 6,000 some odd stars you can see normally with the naked eye. And that's it. But you can lift off the planet and you can fly to, zip around to the rings of Saturn, fly over to Pluto. We were talking about just a second ago, which is not a planet, and we can talk about why in a second. But fly anywhere to any star within the interstellar space within the Milky Way, fly orbit around the Milky Way, and all the way out to the edge of the visible universe. So you can go anywhere in any time. It's way beyond just looking at stars. And that's just the astronomy aspect. Never mind the full dome films, with which Michael and I were kind of chatting about, which can be about anything.
Are you talking about interactively, like in the planetarium?
Yeah, it could be interactive. It's all done live. All the shows, they can all be performed, like all the shows that I performed at least, were all one of a kind because each one was done for the individual show of the day. Obviously, we repeated some special effects and stuff like that, but every show is unique. We had a presenter who would like explain all of the topics of whatever show, whether it was moons, stars, planets, black holes, whatever it was. And then in the back, you'd have a navigator who would do all the technical stuff behind the scenes and operate the software. And so, and that's another thing too, is opportunities for students to volunteer and, get some trade skills potentially that could be useful down the road. That's another thing. Sorry, did that answer your question or not quite?
Yeah, because when you said that you could go, like you could go to Saturn, to the rings and stuff.
Yeah. So you're sitting in your seat, and the operator, the person in the back of the navigator, they, press a button, they lift off the Earth, and then they point to wherever Saturn is, like tonight or tomorrow, wherever, doesn't matter, whenever I should say. And then you fly there, like manually, like you're flying a spaceship with like yaw and pitch and all the regular motions that a plane would have. And then you can settle down like in the rings, and you can upload software that makes them more like refined, like a better image,
and
you can watch them moving.
This is live?
Yeah, you could do it all live.
Where did they get the feeds from?
So it's not from feeds. So the data is in a computer, like it's software, right? Like a video game, essentially.
Oh, gotcha.
But the data comes, and that's a great question. The data all comes from observation data from, all the satellites we have orbiting around Earth and the ones that we have on the surface of the planet, data accumulated over the course of, however long astronomy's been around, the last few thousand years, right? So it's all accurate data from observations made by telescopes. So that's what gets uploaded there. Yeah.
Yeah. This weekend we were camping up in the mountains.
Ooh.
Way far. It was way far.
Uh-huh.
It was like up by Trappers Lake. And about, I would say, maybe 10 to 11 o'clock at night, we were looking, I think it was to the northeast, and we could see the Milky Way.
Mm-hmm.
And then
nice.
Later on that night, I don't know how many hours later it was. It might have been 3 a.m. or something like that. The Milky Way was on the opposite side.
Mm-hmm. Yep. So it should rise in the east and set in the west.
And it was a little tilted on this when we were looking the other way.
Yep.
And I was thinking to myself, I was like, man, it's like, because people who know what our Milky Way is. It's a disk, right? Mm-hmm. Filled with
mostly, yeah.
Right, filled with tons of stars and other planets. And it's what you're looking at is you're looking at it on its side. If you're looking, because you're part of the Milky Way at the edge of it, right? Looking back in it.
Yeah, that's right. Yeah, that's right. Because the solar system, so the solar system is also like a pancake, right? Like a disk. Yep. It's not in line with the Milky Way, so they're like off center from each other a little bit,
right?
And that's exactly.
But we're in the bigger disk of our galaxy, on the edge of it.
I think we're like 2/3 of the way out from the center.
So
like that.
So back to what you were saying about the planetarium. I always thought, man, like if you could just zoom in there,
you can
somewhere. Well, in the planetarium you can,
right?
But not.
That's pretty much the only way it's possible. You're moving faster than light speed to do that. So like to do it in real life is not possible, which is why it's such a good tool, is because a computer can do that. You can fly from one edge of the universe to another instantly. That's pretty powerful.
So essentially what it sounds like to me is like you go on Google Earth and you type in a location, and it kind of like zooms in, and you can control. There's even there's actually a
Yeah,
flight
that's a good
simulator
analogy.
built into
Mhm.
Google Earth,
Mhm.
and you can fly around. So it's the same type
Yeah.
of thing. Because when you said, I've never
Good
thought
analogy.
of a planetarium this way. When I was a kid, I'm like, oh, it's just a video you watch. I've never thought that.
Right.
Imagine it as a
Yeah.
presenter up there and somebody actively controlling, okay, we're going to go to this
Mhm.
planet. We're going to reference all the things that he's talking about.
Because that wasn't possible until computers and modern
point.
technology
Yeah.
got up to that level, and that's totally understandable because that's how most people, like you just described, think about a building like that. You think planetarium, you think, oh, I sit in a cozy chair, fall asleep for a few minutes, and the stars go by. Or you play a movie. Some people haven't even seen movies, like the Denver Planetarium, the Gates one. They show movies pretty much all the time. It was the same I went to the Hayden Planetarium in New York. It was kind of like that because there's so many people in the museum, and they just have to cycle through. So not every planetarium has the flexibility to have a live presenter and custom shows like that. That's kind of a special thing for the planetarium in Boulder that I worked at while I was in college. And we did similar stuff. You'll see some things like in Los Angeles, their planetarium, and then the Boston Museum that I also worked at for a while. Their planetarium also can do live presenters, but it's kind of a new thing. It's like a revolutionary like frontier of new media entertainment, essentially, which is another reason why I get so excited about it.
So how far if someone comes to this planetarium,
Yes.
how far can the software see? Like the existing software that you're using, how far can people see?
What do you mean see?
Like in the distance from the Earth, how far out into the
Oh, we
universe?
can go. So there's a visible like edge that we can see because the universe is only so old and the speed of light is finite. Like it's a number that you can measure. So it takes time for light to travel from one distance to another. And so there hasn't been enough time, literally, of the age of the universe for us to see farther than a certain point, right? So how old are we, like 13.82 some odd billion years? So it's that long for light to travel. And light couldn't always travel, too. That's another interesting thing is it took, this was my kind of area of interests, I should say, too, as an undergrad, was cosmology, which is the study of the history.
You know, I forgot to mention
Yeah.
that Ariel
Oh.
graduated with a bachelor's in astrophysics
Oh.
from CU Boulder.
That's the thing
Just
that happened, yes.
Kind
All right. Thank
just
you.
kind of want to throw that in there.
That's good context for the audience. Yeah, I'm not just some, random guy you picked up off the street.
Rogue planetarium director.
I'm sure. I'm kind of a rogue planetarium director in a way because I'm trying to reopen mine on my own means. But rogue astronomer, now that's dangerous.
Sorry, I interrupted you.
No, you're totally fine. Thank you for adding that because I forgot to. The universe was 300,000 years old when light was first able to move through it, because before that it was too thick and dense and light wasn't actually able to move through the universe. So it took time for that to even happen. And then since then, that's about how far back you can see. So that's our quote unquote bubble of how far we can see.
Because it was blocked by particles and other mass or something?
Yeah, at that point. Yeah, the whole universe, because that's kind of the whole theme of the universe. It starts out hot and dense, and then over time it expands and thins out, essentially gets colder, etc. So hot to cold, dense to thin, and that's kind of the whole history of the universe in a nutshell, essentially. So when it was too dense, light couldn't move. So it took time for that to happen. Then light could travel. So the point is, the universe, we don't know how big it actually is, but we know how big we can see. We know how far we can see, because that's just math. That's like how long light has been allowed to move.
Yeah, so how you're saying 300,000 years you can see?
Okay, so this is a good question too, because it's easy to confuse. So separate time and distance.
Right.
The age of the universe is 13.82 billion years.
Right.
But the universe is accelerating and how fast it expands, and we can talk more into depth about what that even means, because that's just kind of an obtuse statement. But it's getting thinner really fast. That means that our bubble is actually bigger than 13.82 because it's growing faster than that. It's like, I think the diameter of the universe is like 93 billion. I think. Yeah. Someone could double check and put it in the comments if they want.
The what is 93 billion?
The diameter. So like how wide the sphere is. Like from edge to edge.
Of the universe.
Yeah. The visible universe.
Visible universe.
That's the key, is visible. Because we don't know how big it really is. Could be infinite, maybe not. Like you can't say for sure. And everyone's got an opinion that's equally correct. But
so did I misspeak when I asked how far back you could see? Because
no, not necessarily. I just had to clarify like what you meant, because it could have meant a few different things.
Because you can only see back to a certain amount of time or distance in time.
Yeah, and that's a cool thing too to think about. Like, I'm not. This was a great thing that one of my university teachers taught me. He was like, "I'm not seeing you the way you are right now, right? Because it took some time for the light to bounce off you and hit my eyes. So I'm seeing you as you were a couple, I don't know, like trillions of a second ago or something like that. But that's like true for everything you see. So the farther back you look in space, the farther back you look in time. So you're literally looking back in time as you see things.
Yeah, all the kids in school know that the sun is
time travel.
The sun is what, 8 minutes away from us?
That's right.
Approximately.
Yeah. Good. Yeah.
What Jupiter is about 8 seconds is what we're seeing. If we look at that, we're looking
from
that,
us.
Yeah, we're seeing that 8 seconds ago. We're not seeing it. If you had a telescope here on Earth and you're looking at Jupiter, you're seeing it like 8 seconds ago or something.
If that's what you remember, I haven't memorized the numbers from like
I don't remember
Earth 2.
Sorry.
So,
but the point is, you're not anything you look at that's of significant distance.
Mm-hmm.
You're seeing it minutes, seconds, could be years, could be a million years ago.
Mm-hmm.
Yeah.
Or it's longer. But that's a good segue, actually. That would be what you just brought up about how far away things are in terms of light time, right? A light distance. So the sun is 8 light minutes away. And that's kind of a weird thing to put into context. So that's all of that like that whole thing, like how big things are in terms of that. That's chapter 3. All of that is chapter 3.
Nice.
And that's kind of the dedication. Chapter 3 was the fun one because that's what I did for work is, and what I did during my graduation too is actually we would take people on a tour from the Earth. We'd lift off the Earth and fly all the way to the edge of the universe and explain all the things that you would see along the way. And being able to really understand this, well, we'll come back to that in a sec. But that's kind of the premise of things is how far away. So like a beam of light travel around the Earth in 1 second. It would take about that time to get from the Earth to the moon for a beam of light. So you think like, okay, how long is a second? And then think, okay, now how far away would that be to the sun? And you kind of go from there. And I start with something simple like how far you can see to the horizon. That's about 3 kilometers or 5 miles roughly for the average person, like how far away you can see. And I start from there. So like how far away can you see from the horizon, and then go like the circumference of the Earth, and then convert that to light time, and then go all the way to the edge. It's a lot, but
that's wild.
You can read about it.
According to Google, 93 billion light years.
So I got that. Okay, good.
You are correct.
Cool.
28.5 gigaparsecs.
Oh yeah. So for anyone in the audience who doesn't know, or for you guys, parsec's just another unit of distance. It's more convenient for things in the side, like from a certain distance within the Milky Way farther out. So like professional astronomers might use parsecs for their data.
I feel like most people would know that number from Star Wars.
Yeah, that's or the word. Yeah.
The Millennium Falcon did the whatever and however many parsecs.
Wait, is that Star Wars or Star Trek?
That's Star Wars.
That's Star Wars. Yeah, Millennium Falcon's Wars.
Millennium Falcon.
Okay, yeah. I don't remember. Wait, how did they use it again? What did they say was the line?
It did make sense because I think they used it as a measurement of time.
That's what I thought.
Yeah, they said they finished the race in like 8 parsecs or something. Like that.
Right. Yeah. So that's incorrect. Yeah, it's a distance. Yeah.
But they got close. They almost used the right word.
I mean, for what it is, it's a fun set of movies, but it doesn't have to be accurate. You shouldn't expect it to be, but it's kind of funny to look at the inaccuracies.
Yeah. So what do you think the probability is of us colonizing other planets, and how far can we go? How fast? I mean, you and I talked about this before. It kind of depends on resources that are available.
That's a great question. So, what was the joke they made? I'd like to be the first person to buy real estate on the moon. So that's how confident I feel about colonization. Now, you asked a great follow-up about, so I think it's inevitable, certainly within the solar system. And there are a couple points to go off from there. So how far? I'll start with that. How far can we go? Well, that depends on how long the human species survives. And then after a certain amount of, I don't know, a couple tens of thousands of years, technological advancements with genetic engineering, designer babies, you can print off the exact genes you want to for offspring. You can, so once we get to that stuff, when we get to interstellar travel like that, who knows if they'll go. And whether or not you want to call that we, like as humans, that's a separate deal. Now, we're going to have to leave the solar system at some point, right? And this we've talked about a few times with the sun going out. We've got about 5 billion years, 4.5, 5 billion years till that happens. So if we want life to continue at all, as we understand it, we have to leave eventually. Now, in terms of resources, I mean, it's important to keep in mind, too, that at that point, we would probably be harvesting stars as fuel. So it's not like just mining things. It's like, in terms of energy, it shouldn't be an issue per se. Michio Kaku, if you've ever heard of him, Japanese physicist, very popular author. He's got this famous thing that he always goes on about type 1, type 2, type 3 civilizations. Have you guys heard of this at all? So these are tiers for civilizations on how far with the colonization thing we've gone.
Would that be like robots?
No.
Humans as we are now?
Not quite. That it's based on how we get our fuel, essentially, how we get our energy, and what scale that is. So we're almost a type 1. Not quite. We're almost type 1. Type 1 would be where we essentially, I think, harness all of the energy of our planet. Type 2 would be... No, I'm sorry. Type 1 would be harvesting all of the energy from our star, just our solar system, which is 99% our star. First the star, and then the galaxy, I think, would be type 2. So we colonize the galaxy. That's like Star Wars, essentially. They have colonies all over different planets, and they're all connected with each other. They all communicate. That's like type 2 civilization. Star Wars is type 2, I think. And then type 3 is intergalactic. And that's like... Okay, so...
Other galaxies?
Yeah, it's other galaxies,
that's
and
that's Star Trek.
Hard to do. Yeah, that's... People don't understand how far away things are from each other, I think.
Yeah, the fastest we can go right now, is like 17,000 something miles an hour?
I don't know. It's fast, but not light speed.
Is it that fast? Or you don't know?
No.
But that's not fast enough.
I've seen the number, I'm sure, but I don't commit it to memory.
But it's not fast enough.
Well, I mean, it depends on what you want to send out. If it's just a probe, it's pretty good.
Yeah, and if you had robots working on it,
and
on a spaceship or
and
on a probe.
Yeah, and maybe something that could repair itself while it's out there too.
Yeah,
something else.
It could have energy.
Yeah. The thing though is like, it's important to keep in context with like how long we've actually been doing this thing where we go to space and stuff. So Voyager, right, the farthest thing, I think Voyager 2, farthest thing out there, just left the solar system. But I mean, when did we send that out? Like in the 50s or 60s or something like that. And so that's not that long ago, contextually. Like we're talking hundreds of thousands to millions to billions of years till the sun goes out, and we've only been doing this for 50. That's nothing. That's a blink of an eye. Less than that.
1977.
I was way off. I'm sorry. 77 is when Voyager. So that's even less time. That's even more impressive.
Yeah. And our fastest speed is 24,816 miles per hour, and that was the command module of the Apollo 10.
Very good.
So
Thank you.
Pretty slow in terms of space travel.
Yeah, relatively.
But like you said, we're just starting off.
Real infancy. Like infancy is like an understatement. It's like pre-fetal phase.
Yeah.
Is where we're at with space travel.
It's pretty exciting, man.
It's very exciting.
Very exciting.
That's why it's a good industry to get into.
So first we're going to the moon. We know
You have to start with the moon.
We know that's happening.
Yeah.
Because the Chinese are looking at doing it. Elon Musk is looking at working with NASA to do some stuff, right?
Yes, and this is a really good point to, that we talked about last week too. That I want to reiterate is, I mean, everything in outer space in terms of like ownership and like who goes there. As you were talking about, like, you know, the Chinese are looking to go there, yada yada, and it was the same thing with the Russians and like. So when we talk about colonization of space, it's essentially like Antarctica, right now, right, where it's owned by everyone, but there are pockets where people are, and there are flags there, and it's pretty well understood.
Yeah, I think it's pretty
you know.
broke up. People kind of
Yeah.
claim certain areas.
And eventually that's going to happen with the moon, and, you know, people are going to claim territory. And so I joke about the real estate thing, like buying land on the moon, but yeah, I mean, someone's going to be there, and it's like, what did you say? Like, who's going to move me? Who's going to kick me off, right? So
Yeah, right. If you're the first one there, you're going to say, all this is mine until somebody decides to fight me for it.
And they will.
oh yeah. So I mean, because there are resources there. I mean,
Yeah.
The moon's great for mining. There is water on the poles that you can harvest as well for fuel. And
Is there water on the poles?
Yeah, a little bit. Yeah, frozen water. Mm-hmm.
Nice.
There's water on the moon, a little bit. Like
I didn't know
not
that.
a big deal. Yeah. I think they found it buried. Like, it's under craters, probably from comets, if I were to guess. Be the most likely thing, because if it's on the surface, it must be pretty recent. That's another fun fact for you too. If you ever wonder, or anyone in the audience wonders, how do we know how old things are in the solar system? Like, have you ever wondered, like, how do we know how old the surface of the moon is? Like, how do you determine that?
You can't get up there and well, you can get up there, but we haven't carbon dated it.
Yeah. Well, one of the methods, like if you look at, say, Mercury or any other foreign body that you can't go to, you look at the number of craters, because that determines how fresh the surface is. And that also helps you determine whether the surface or the planet is alive or not. Like Venus is volcanically active like the Earth is. It's got, you know, a changing, alternating surface. Its geography alters over time. So it's alive, geologically. And so looking at craters is a very useful way that that you might not think about to determine, like, different attributes of foreign bodies like that. So
Can that be flawed if there's a lot of asteroids in an area, though?
oh sure, yeah, no, it's not. Like I say, it's just one method.
Yeah.
And that's all of science, but astronomy especially, because with astronomy it's all mostly what you can see. You can't go out and touch distant galaxies and stuff like that. So it's all what you can see and analyzing light, being very, very good at understanding electromagnetic rays, which is what light is, radiation, and being able to parse out information from that. So there are multiple layers and multiple methods for all of the different, you know, things that we want to measure, like age of planets, moons. So that's just one, is counting craters.
Yeah, I found that interesting. I told you I took that astronomy class, and it's
Yes.
it's like everything's based on, you know, it's all math, science based or whatever, but it's all based on what you can see and like how
Yeah.
long you've observed it for. And we
Yeah.
talked, I mentioned
Mhm.
like calculating blue shifts and red shifts, and that's
Mhm.
all based on just watching things over a period of time and then applying math to it, right?
Oh, well, that, my friend, you just described all of science in general perfectly.
I guess
I mean, and that's, I mean, it's a process, right? Like, you observe, take notes, try to find patterns, make predictions, either they're right or they're wrong, and then you do that a lot over and over and over and over again. Then you tell your friends, and then they tell you why you're wrong. And then you do that over and over and over again. And then over a couple thousand years, you get refrigerators and computers and all the technology and whatever that we have.
Yeah.
Essentially.
Yeah.
But to go back to, so with astronomy, though, but it's very specific because you must use light specifically. And so you're talking about redshift, blue shift, right? Do you remember what those were by chance? Because that ties into
Let's see.
what we were talking about earlier also.
Redshift is a planet that's moving away from us as it turns more red. It's
Yeah,
traveling
anything,
further
not
away?
just a planet. So
okay.
galaxy,
Yeah, and then blue
yeah.
shifts are things that are traveling closer to
Mhm.
us.
Yeah, it's like, you remember slinkies? And I use this with my students too, is I have a rainbow slinky. And so the blue shift is like when it's getting squeezed together, like the accordion gets closer together. And then redshift is like it's being stretched apart. So like as it's going away from you, the light gets stretched.
Gotcha.
Yeah. And so.
And that's just based on wavelengths, right?
Yeah.
How much they get stretched as they travel.
Yep, that's a measurement of wavelength. Yeah, and wavelength shift, I should say. But that's how we determine how old the universe is. Also, is by measuring and how fast it's accelerating. Is that redshift, blue shift? Very important. A lot of applications to that. I used that actually in a project to look for exoplanets. That was the one sort of research project I actually did in college was exoplanet research. I just fell into it. Looking for something to do, but it was pretty cool. But part of that is like how fast is it spinning? Because one half of the planet is redshifted because it's moving towards you. The other half is moving away from you. So the other side's blue shifted. So if you measure the difference between those, right?
Wow. So even on a single object, you can use
Yeah.
that to determine, like how fast it's spinning or
Exactly.
which way it's spinning.
Mm-hmm.
Wow.
Yeah.
So there are a couple other things. I'm not trying to be, the sad person in the room or make people depressed.
Oh, we can compete for that. That's no problem.
The universe is expanding and accelerating.
Yeah.
Faster and faster.
Uh-huh.
And that will not slow down, as far as we know.
As far as we know. Now, we don't know for sure. Like, nothing's set in stone, but
And energy is being used up. So
that's entropy, man.
So one day there will be no energy left.
That's one thing I gotta make sure. Technically, energy in the universe is conserved, except not really on an open system. Actually, it's weird because more energy is being injected. That's why the acceleration is expanding, but it's dark energy. But essentially what you said was pretty much great. So everything's gonna thin out, cool down. All the energy will be dispersed. Is kind of more. So it's not like so if we have a big puddle of, I don't know, like clay or whatever, it's like really dense and then you flatten it out. So it doesn't go away, right? It's just thin and spread out all over. That's more like what's going to happen with the universe. So it's going to be so thin and everything just sort of blissfully fades into darkness.
Just the lights dim for everything.
But interesting hypothetical. So here's a pop quiz. What are the last things that are going to be left behind at the very end of the universe? Take a guess.
Twinkies.
No. Good guess, though. On Earth, yes. But in the universe, in the whole universe, after Earth is gone.
He said Twinkies. That was great.
That's a good answer.
In the whole universe.
Yeah.
What is going to be left?
Yeah, so think of all the space things planets, white dwarfs, quasars, whatever words you might have heard in the news, whatever.
I mean, if I had to guess, I would say more solid state things like rocks, stuff that was hard, dense, rocky.
Yeah, I would say, I was going to say like asteroids.
What's the most, you're correct. You're on the right track, I should say. What's the most dense thing in the universe? Because it's not rocks. And it's not diamonds.
I wasn't prepared for a pop quiz. Dark matter.
Close. I don't know about dark matter. Black holes. Black holes. So that's the last thing, but they do evaporate. It just takes trillions of years. So the universe will be, a googolplex, like 10 to the 100th power. So like way old. Way old. And it'll be dark, but there will be black holes technically. And the thing about black holes is when they evaporate completely, they explode and release a tremendous amount of energy. Who knows? Maybe those explosions cause new universes to be born. Maybe. Could be the source of new universes.
Dum, dum, dum.
Maybe. So, and that's like, it's fun to think about, but it's like so far into the future. It's like, I don't know what I'm going to eat for lunch tomorrow. So it's like,
oh yeah, you're talking trillions of years for this kind of stuff.
Oh yeah. The last stars, by the way, will be 1 trillion years old. 1 trillion.
1 trillion?
Yeah. Those are the little tiny red ones that are smaller than the sun. The sun will last about 10 billion. So if you think 1 trillion, you go from 10 billion, 100 billion, trillion. So that's 100 times longer.
So not trillions. We're looking at approximately a trillion for the last sun to burn out.
For last star, yeah.
Last star.
Yeah, sun's a star. You're
Sun's
right,
star.
Yeah.
Do you remember that movie? I think it was Matthew McConaughey.
Martian?
Interstellar.
Oh, I'm thinking of Matt Damon.
I think he was in a black hole, I think, in the movie, wasn't he?
He
Where
did
it was
fall
all
into a
kinds
black
of
hole.
like, everything was twisting, and it was like, because, for people like us, me at least, trying to wrap our heads around what we think a black hole is.
Yeah.
Do astrophysicists even know what a black hole is yet?
I think some have really good ideas. So you have your first name that comes to mind is Leonard Susskind. He's the author of Black Hole War. And then obviously you had Stephen Hawking, and I haven't read quite enough of his work right now just because that's not my focus of study. But I have some books on my list, obviously. But I think the number one person that I think of when I think of black holes was actually my final advisor for college to graduate. So just a brief story. So I finished my degree, my bachelor's degree, in 3 years, right? But the thing about college is they have multiple tiers of requirements for you to graduate. So obviously there's the credits, right? You take this class, you get that many credits. But they also have this thing like upper division, lower division. I remember this. So upper division's like junior year, senior year, and then lower division's first years. Well, I didn't have a senior year. So I didn't have enough upper division credits, but I had enough credits to graduate. So I had to do this weird thing where I did this one credit that was an independent study, and I could do it on whatever I wanted. And I decided to do it on string theory because I'm insane, I guess. And my advisor was an expert on black holes. And his name's Andrew Hamilton, a professor at CU Boulder. Brilliant guy. And he has made simulations about black holes that he shared with classes. And I don't think he says he's not ready to publish. I haven't checked up on him in a couple years, but I feel like he would have some really good insights on what really happens when a person falls into a black hole. There's this stuff that you'll see on the media, like spaghettification. You guys heard of that?
Yeah.
Kind of like
You get like stretched out.
Yeah, because of tidal effects. Yeah, because your feet get pulled more than your head, so you get stretched out. So stuff like that, and then time freezing, like you experience all of time at once falling in, but weird stuff like that. So there's stuff in the mainstream media, like Interstellar, but the most accurate answers are kind of people like that, I would think of.
The one I always think of is it's just like a time warp. You go in on this side, and then you come out in like another galaxy somewhere.
Right.
Like it's like a time warp.
Yeah, or like a wormhole. Yeah.
Yeah, wormhole. Yeah.
Yeah, and that's another idea. And I don't know. I mean, I try to keep up with the news because people come up with new equations and new adjustments to Einstein's equations to make different things work. And I mean, but it's not definitive enough for me to have I got to stop and read this right now. It's just more updates kind of on different ideas and
I assume that
gradual.
Part of the issue with figuring out what a black hole is because you said earlier the most important thing for astronomy is light.
Bingo.
And there's none in the center of a black hole. So you can't.
It's black.
You just don't know what's happening, right?
Yeah, all the light falls in, doesn't come back. We can't see it. It's like,
it's like your one tool is gone.
The biggest thing, so that's the primary thing, is the observational component. But there's a theoretical part of it too, which is a big issue, and it's another very mainstream science problem is merging general relativity, which so Einstein's equations about gravity and how galaxies and large-scale things move, and then quantum mechanics, which is about all the particles that everything in the universe is made of. And they don't jive mathematically. They use different mathematics. And this actually I can speak with a little bit more authority on because I took a quantum mechanics class and I took a general relativity class before I graduated. And you can see, it's just that the math is different. It's not a super descriptive way of explaining it, but it's just the truth. There's a lot of linear algebra, for example, in quantum mechanics. There's a lot of calculus and relativity, for example. So they're just different types of math, and they don't work out when you mix them together, you get infinities and zeros, and it's just terrible. It's a mess. It's just, you don't want to see it, and that's the issue.
What is quantum mechanics?
What is it?
What is it? It's a study of what?
The most fundamental particles in the universe. That's a good question. Yeah, I'd say that. So all the most fundamental constituents of matter and energy. That's what quantum mechanics is. And it's probabilistic is the big thing too. There are no like certain answers in quantum mechanics, but it's the most accurate model, scientific model that humanity's ever come up with. And when people say that, what they mean is it produces accurate predictions. So that's what is the test of a good scientific theory, right? Is if you can use it to make predictions about the future and have them be accurate. So
can you run that backwards and see what particles used to be, or try to guess what particles used to be?
Yeah, what you're talking about is we call it time symmetry. So you have body symmetry, you cut it in half, and it's the same both sides. Talking about time symmetry, same forward in time, same back in time. So if you know one, you know the other.
Because if everything came...
I'll say yes to an extent.
Yeah, because if everything in the universe came from less mass and then became more mass...
Less dense. It's more dense. So all the mass...
Right. Sorry, I misspoke.
Same. It's just how close it is.
I misspoke.
Yeah. No, you're good.
You're right. Yeah, more of a dense mass before, and then...
Dense state, yeah.
Yeah, and then expanded. Was that maybe a different particle or different types of particles, and then it changed from that point?
Oh, okay, yeah, sure. So...
Or is that the wrong question?
No, it's just a different subject, kind of. So, when you say different particle, what I think of is I don't think particles. I think forces, because that's another thing. So there are four fundamental forces. There's gravity. You drop something, it falls. Electromagnetism, right? Electricity, magnetism, and light is part of that. And then there are the nuclear forces. But what you observe is at high energy levels, i.e. at the beginning of the universe, where everything was dense and hot and highly energetic, the forces can start to merge. And we don't, well, at least I don't know since the last time I checked what fundamental particles will change, because there's a list. It's just called the Standard Model. It's actually pretty simple. It's just all the ingredients, basically, that all the, the protons and the atoms and stuff, elements are made of. Now, if that table changes early in the universe when the forces are different, probably because there's a force particle for light and there are force particles for the strong and weak nuclear forces, and if those forces merge, then those particles would emerge. So yeah, that's a part of it, definitely. Different particles, but not different physics. So you should be able to use physics should be consistent throughout all of time. If that's kind of what you're asking with like forward and backward, stuff like that.
Well, it's just amazing to me how when you had the beginning of the universe, when everything was, I know, right? When everything was compacted and super dense and everything was, let's say, to a single point,
mm-hmm.
and then everything was in that package for life. Everything, all the gases, water, rocks, everything was in there.
Mm-hmm.
So when that expanded, it's hard to imagine that stuff coexisted in that state. It had to be something else that when it expanded, I'm not saying it had to be, I don't know. I'm just in my mind.
Yeah, no one does, so it's fine.
Yeah. And maybe that answers my question. So when it started to expand and started to change, then you got different combinations that made other things.
Chapter 9. So that was one, because that's kind of how people say it, and some people really mean it literally, but I don't know. But a common, right, you hear about the Big Bang, and it's like, oh, everything was compacted into one singular point. Well, kind of, except if the universe is infinite, assuming it is, then all points would be that infinite point. So it's not necessarily that the universe was compacted into a point like you could hold in 3 dimensions. It's all 3 dimensions of space and time are uniformly dense. Like the whole universe is just thick and dense, and it's just all of it. And then it just sort of thins out. But it's always the universe. which is super weird. But you can't really think of it as a 3-dimensional like thing you could hold in your hand, or like a point that's squeezed, like that's here or there, because there is no here, right? There is no there. It's all here, and it's all there, and it's everywhere and nowhere, and it's like that quantum, duality type thing. It's that superposition throughout the whole universe.
So
it's weird.
Man, that is.
Am I getting this right? So you said every point is the infinite point, and by that you mean there's like.
That's how I describe it, at least.
Because it is infinite, there's no standard point to measure. There's no like edge to measure off of. So any point can be measured off of any other. Like it's.
Every point in the universe is the center. That much you can pretty safely say, based on observations of the uniformity of the universe, that you can actually observe. The universe seems uniform. You can measure that through like the cosmic microwave background, like the static that you hear, or that you saw on your TV back in the day when they had static on TV, or on your radio. You can measure things, and you see that the universe is pretty uniform. That's why I say, like, okay, if it's uniform and it's infinite and it's thinning out, then everywhere is thinning out, and everywhere was like the singularity point. If that makes sense or not, I don't know. But people can argue about it in the comments.
I know I'm putting you on. I'm putting you on the spot.
I wasn't ready for a quiz either.
I'm putting you on the spot.
I kind of was,
because I think even a lot of astrophysicists, they don't have these answers.
It's
either.
A contentious topic. Yeah, for sure.
I am asking your opinion. Sorry, I'm not asking you for the answer. My apologies.
Oh yeah, I mean that's all I can give you at the end of the day.
Yeah,
so
yeah.
That's okay. But I can give you an educated opinion at least, because at least I went to school for this stuff. I was very serious about studying these things and it's just the basics. Like what you can get from an undergraduate degree in just 3 years, especially, is only so much. It's continuing, ongoing education that people will do. I had actually, as a side note, a little segue, a little diversion, tangent. I had a student once. I want to say he was in his 70s, 60s, like late 60s, early 70s, and he wanted help for astrophysics because he had wrote his own paper and he had some controversial ideas about things. But I was like, he was that old and still doing research and trying to write papers and doing math, and so it's lifelong pursuit.
So let me ask you, trying to put this the right way. So it's not a matter of how far we can get, because that depends on a lot of things: resources, energy, technology, how much technology can it advance, how much we know we have a certain amount of time in this solar system before this sun's gone.
Right.
And then we can, if we were able to get out of this solar system, if that technology ever did come our way, or we ever did figure that out, we will have to, the next step is, are they called other solar systems in our same galaxy?
Yeah, you can call them other solar systems. Yeah, they
Right.
are. Yeah. Huh?
But all of the suns in our suns/stars in our galaxy, they also have life terms on them as well.
Correct.
So we would have to be trying to chase a chain of, if that's what we needed, if we even needed suns at that point, we would maybe have to chase them. And as we're chasing those are burning out, if we're lucky enough to chase them. And then if we were able to get out of our galaxy, the next closest one is Andromeda. And
good job.
You still have the same issue. You have to keep chasing. And actually Andromeda is coming closer to us, correct? We're going to merge with them eventually with that galaxy.
Yeah.
But moving beyond that, you would be chasing other things that are moving away from us. So we would have to, I'm glad we're doing it. It's great. And I think, why not? Especially
what else we're going to do
with
our time here,
especially with mining they're talking about mining other planets, mining,
moons,
asteroids,
and comets. Yep.
Yep. Could you mine it? Comets? So comets are described, they have ice, right?
Yeah.
Is that the difference?
That's the main distinction. They also come from a different part of the solar system.
Yeah.
The asteroid belt is, so it's Mercury, Venus, Earth, Mars, asteroid belt, Jupiter.
Yeah.
And then Saturn, Uranus, Neptune, Kuiper belt, where Pluto is. And then way farther out is a place called the Oort cloud, Oort, and that's where the comets come from. That's why it's able to be ice. It's like denser things in the center, right? Rocks in the middle, and then ice.
And I want to get to the mining. I know I want to talk to you about that as well. But
Sure.
So our issue, our challenge is really time. That's our challenge, not necessarily
That and the fact that the universe wants you dead really badly. Like, it's very hostile.
So you got right to the point. That's where I was going. I mean, there's no outrunning it. I mean, eventually you're going to hit the point. I mean, unless we get some crazy technology that allows us to chase things that are moving further away, and then also.
Oh, well, I just mean on the way, like, cosmic radiation from the sun, and the fact that you can't breathe on most places.
But if you could mitigate all of those dangers.
Right. And I'm sure we can. But yeah, in the long term,
I mean, so is it possible? You spoke earlier and said that the energy was never going to completely go away. It's just going to be stretched out so much that it's not together in a way that you can use it.
Right. Because energy coalesces into matter. All the stuff, right, that we're made of, all of it is just like congealed energy, essentially. So that's the way that friend of mine put it.
So you would have to have some like space vacuum cleaner that was just trying to suck up all these little energy particles to make enough energy to utilize at that point. Once the energy is all dissipated, and you're trying to find it and get it and gather it, which would almost seem to be impossible.
Well, I mean, and this goes back again to the black hole thing. I mean, the nature of the universe, this is the second law of thermodynamics, is the law of entropy. The universe expands, thins out, and things go from hot to cold, high energy to low energy. So that's the nature of things, and that happens to everything, including black holes, but they're sort of like these repositories of matter and therefore energy. And so as they're the last ones to go, when they detonate like that, that'll be like the last hurrah of the universe. And then from there, I mean, who knows? Who knows what could happen? Like, I don't know. That's not for us to say.
You know more than I do. That's for sure.
Well, about certain things. But everyone, I say everyone is a genius at something. So, I don't know everything, but I know some stuff about things and some things about stuff. So, I just do my best. But thank you for the compliment.
So the mining.
Yeah.
That's an interesting one.
That's pretty exciting.
And I've read some of it where they're not really planning on bringing anything back here.
Not worth it, really.
It's not cost effective. It'd be really hard. They're trying to use it. They're trying to mine and use as they go.
Yeah, and it's not necessary because you just pick stuff up where you're at and then pick up what you need where you're at and then keep going, like a gas station.
Yeah, and they're thinking they can probably mine. There's all kinds of stuff on these asteroids and comets and other planets.
Oh yeah, I mean, when you think about it, it's all the same stuff, more or less. Well, it is all the same stuff. Then it's all protons, neutrons, electrons. But on a grander scale, it's all the elements on the periodic table, and the stuff specifically that you can find on a comet or asteroid. It's stuff that it didn't get formed into a planet, obviously. But what that means is there's stuff that you might only find in, say, like the core of a planet or a moon. Like, all the nickel and the iron, stuff that's very sparse, the heavy metals that you wouldn't find a lot of on the surface of a planet because it's so dense. It'd be a lot easier to find all that stuff on an asteroid because it's just a smaller rock floating around, but it's all the same material.
I call it stuff. I feel like I sound like Jonah Hill on Don't Look Up.
Stuff. I know.
Everybody,
I was thinking about that movie. And I'm sitting here like you guys are talking about this, and I don't even know what are they trying to get off asteroids. I don't know.
Stuff.
Yeah. Okay.
Stuff to make things go.
Stuff, but like what?
But resources, right?
What resources are they? What resources would they be able to mine that would allow them to continue exploration?
So again, there's water, right? We need that to live, and it's also a good fuel source. Oxygen, hydrogen are pretty basic molecules in organic compounds, so you can use them to synthesize other things. So, if you've got stuff like organic compounds and maybe stuff like nitrogen to feed your plants, phosphorus, right? Because plants need that stuff for fertilizer. As an example, just off the top of my head, obviously the metals, which you need for electronics and communications and protection from interstellar space.
So basically everything.
So
Things for sustenance,
so
things for continuing.
yeah, and I know it is broad, but again, we're talking about all the same stuff on the periodic table you can find on Earth, and whatever you can use that stuff for, all those ingredients for on Earth, we would just do on a micro scale in a spacecraft. So
just think about everything on a broken down
Yeah.
molecular scale.
And it
what can
is-
we use to
yeah.
combine these and create.
Mhm.
Yeah.
Yep, it's the most bare bones ingredients. Yeah, because you're obviously not going to find plants and cows and
Yeah.
whatever else. No space cows, unfortunately. But the stuff that cows are made of, if we can 3D print meat, which we can do now, you just need the proper ingredients, the ink, quote unquote.
I've
and,
seen it. And it, I don't know. It grossed me out.
Really?
It's pretty
I haven't
gnarly.
seen that. Printing
Yeah.
meat, like actual
Yeah.
protein meat.
Oh yeah, and it's kind of exciting for me, at least in the medical industry. Like if someone, you don't have to be on the donor list for too long. If you need a new heart, we'll just print you off a new heart.
What are they using for the materials to make that?
I don't know specifically what they use, but I guess since we're talking about basic compounds, so like you can look at what muscle tissue is made of, the right amino acids, and if you chain them together properly, you can make an organ. And they have to do it cellularly, I'm pretty sure. So we're not talking about molecules anymore. We're expanding it out
It says
way
lab
time.
grown stem cells.
Cells. Yep.
Stem cells.
And it makes sense to use stem cells, right? Because they can become anything. So
Wow.
organize stem cells in a certain way to make a lung, and they'll form themselves into the bronchioli and the little
Yeah, this says
wiggly bits.
layer by layer, 3D printed meat is constructed or scaffolded from a bio ink that extrudes out of a 3D printer nozzle.
Yeah.
So the
Have-
stem cells can become whatever type of meat you want it to be, but we have to direct it to become
Yeah.
a certain thing or whatever.
Yeah, and those are based on different genetic markers, I think, like hormones and proper enzymes, so that way they activate in a certain way to become the right organ. So, I mean, have you guys seen a regular 3D printer, like with plastic, stuff like that?
Yes.
It's that, but with cells instead of plastic.
It's wild.
Will it have
Crazy.
like meat fibers?
Yeah, I mean, I
Well, it should
looks
be
like I
identical,
See a picture
hopefully.
right here of a hamburger being printed. So
Well, that makes sense.
yeah, because I mean, we use stem cells now. Say you have a knee injury, you inject them into your knee, and then they fill in gaps
Yeah.
and form whatever you're missing, right?
Right, yeah.
So whatever it should be exactly like meat, as long
Yeah.
as you can tell it to form whatever type of.
Right, and they adapt to
musculature
your
you want.
body because they're in your body, right? But if you program them outside of a body, you can make them whatever you want.
So do you think if you made a heart, and of course this isn't your area of expertise, but
Right.
If
Yeah,
you,
that's
if you
good
made
preface,
A heart
yeah.
that was printed out of stem cells because they do adapt. If you then put it in a person, do you think it would have a higher rate of taking? Because when you get a heart transplant,
That's a great question.
it's not super high, right? I
Right.
don't know what the percentage is.
I don't either, but yeah, that's the thing with organ transplants is not everyone's compatible. So you could, if you should, from my understanding, be able to tailor the genome of those cells in order to be tailor-made specifically for that person. That should be completely doable, especially with CRISPR, if you've heard of that.
Yeah.
That new genetic modification technology.
Gene editing.
That's what I was talking about earlier when I was referring to designer babies. I don't know if that was while we were recording
Yeah.
or not, but down the road.
Bespoke
We're out in
babies.
space. Yes. So
So maybe that's the food that they take on these spaceships.
It's Soylent Green.
I was like, babies?
It's people.
No, not babies. No, maybe they print food, like in the Jetsons. They just
or
have a machine.
That's what you'll have to do, probably.
Star Trek. That was the whole thing. Basically a 3D printer for food. It materializes in the show, but
Yep, that would probably be how, or the method, or because growing food is important for like the International Space Station, right? Like if you're in one place, you want to be able to, like if you're or colonize the moon or Mars, you want to be able to grow crops because agriculture is the bedrock of civilization. So you need but that's if you're starting a civilization. If you're just a nomad traveling through space, you're not going to grow crops, so you're going to need some other way of getting your nutrients. So 3D printing.
Yeah, what do you think that how many people do you think eventually will have like private? I know we already see it now, but like maybe some rich guy has something in his garage. He's like, "Oh, I'm going to space for the day." Flies out, goes to space. I mean, do you think we'll ever see a day like that in our lifetime?
Oh, in our lifetime, I would
not
be surprised.
not far. I mean, just like outside of our atmosphere or in our atmosphere at some point to some elevation.
Oh, like and you're just talking like the upper class, like super uber wealthy people in their backyard.
Or would it still have to be like
when people first started writing planes type thing?
Yeah. Or would it have to be like there'll be companies that like airlines?
Because they have.
It'll start with that, like Virgin Galactic.
Virgin, right? They already have that.
Yeah.
But you don't. I wonder, will it come to a point where there's just private people that are doing it?
Yeah, like an individual, like I could buy a jet for myself.
Yeah.
I'll buy a rocket. I won't say. I mean, it seems like that's the direction we're going. I wouldn't be able to predict a time frame, but something like that seems inevitable. Now, it would probably be for travel, because you can get a rocket up and then you kind of just, it's kind of cool actually, because you would just lift off the Earth and you would just kind of stay there, and as you're falling, the Earth would just rotate underneath you, and you would just, so basically from your perspective, you just go up and down, but because the Earth is rotating, you might be in your destination, which would be kind of cool.
Yeah, depending on how long you stayed up there.
Yeah.
Yeah.
And if you want to go, west or east, that's a big thing too.
Yeah, sorry, we're taking you outside of your
well, it's
realm
still
of,
space related.
Yeah.
Everything is astrophysics because we live on the Earth, and the Earth is in space, and all of nature abides by physics. So, everything is in my wheelhouse. I shouldn't say that. I'm just kidding.
All right.
I'm not an expert on
next?
everything, but I'm happy to chat about anything. I mean, that's why the title of the book is Everyday Things with a Cosmic Perspective, right?
Right.
Because, I mean, anyone can chat about anything, and that's fine, but that's my background. That's my perspective, is from the perspective of a person who regularly flew off of the Earth and flew around the universe for a living and has been to the edge and back more times than he's been to the grocery store, maybe. That's probably an exaggeration, but you know what I mean? So cosmic perspective and thinking about that deep time, how, thinking in terms of trillions of years. So that perspective applied to regular stuff. So like travel, mining, resource management.
Okay, I got a question.
Bring it.
I have seen, there's a theory that you can space travel because we have limits, right? We can't travel faster than the speed of light because then
Unless we move space.
Right. So that was going to be my question. The theory that you can wrinkle space-time, right?
Yeah.
It's almost like folding a piece of paper and then you just jump the gap and then unfold it.
Uh-huh. So,
is that real?
So that wrinkling of the paper thing, that's what a wormhole is. You take one point, another point, and they're separated by three-dimensional space. So instead of a flat sheet, it's three-dimensional, right? Mm-hmm. But you tie them together, wormhole. Now, the idea of wrinkling space-time, because it's one thing, right? It's space-time interwoven together. It's one fabric that we live in. It does wrinkle, and that's proven through our observation of gravitational waves, which technically happen every time anything with mass moves, but it's most noticeable when the biggest things move, which makes sense, right? So when neutron stars or black holes merge and collide, they create ripples in space-time. So maybe, what if we could harness those ripples, maybe generate them ourselves with some sort of technology, and use them to zip through space faster than light? Maybe. I think it's called an Alcubierre drive is the name of at least one of those designs. But yeah, that's potential.
So it's an
Maybe.
idea that theoretically seems possible, but we have not even close to the technology to attempt it.
Yeah. And a good thing, I think, to clarify, too, for everyone is when we say theoretically, when I say theoretically it's possible, what I'm saying is the math works out. So, the math checks out and you can do it. How you would do it and what technology you need, what resource you need, that's like the experimental side of physics. So there's theoretical physics, experimental physics, and they go together to create like actual theories.
You need theoretical to do the experimental.
Yeah. And you need theory to guide the experiments, but sometimes you just do enough experiments and you just pop along some sort of theory. So they go hand in hand, right? They feed off of each other, and you need both to make a real valid like scientific prediction. But yeah, that whole rippling of space-time thing, that's definitely theoretically possible.
Have you guys, when I say you guys, I mean your community of astrophysicists, is there anything that the James Webb Telescope has helped discover as far as like understanding our universe?
Probably, but I haven't really been involved in the astrophysics community since I graduated college.
Yeah.
So
yeah,
it's a little bit. You should ask if you're watching this. Ask your local astrophysicist as well. Call them up. Find a directory.
yeah,
like your local doctor. Ask your local astrophysicist these questions as well. But the answer is definitely yes. I have no doubt that James Webb has supremely enhanced scientific endeavors of a lot of modern day researchers.
Sorry, correction. I said James Webb Telescope. It's James Webb Space Telescope.
Oh, yeah.
Telescope. And according
Again,
to Google, it's
say it all
discovered
times.
717 ancient galaxies. And that's a leap from only a handful that were previously known.
And that's what it was designed for. See farther towards the beginning where the first galaxies formed. So it's brand new data also.
Right.
Never before seen.
Months. I mean, we're talking months here,
Mm-hmm.
I think.
And not just like brand new for us, like, well, I guess, yeah. Never mind. I don't know where I was going with that. But yeah, it's a couple months old. So people are going to be combing through it for decades.
Does the James Webb Space Telescope help with seeing those ripples and other things like that? Or you can't really detect that kind of stuff, right?
No. So the ripples of space-time, those were actually ground detectors. I was still in college when we discovered it. So I think it was 2016, something like that. It's called LIGO, like Lego, but with an I. Laser Interferometer Gravitational Observatory, I think, something like that. They use lasers, and they see how the light, like we were talking about redshift, blue shift, we see how the gravity changes the ripples of the light through two different like perpendicular beams, like an L shape, and through that measurement, they measure gravitational waves. So that's how it's done right now on Earth with laser beams and very, very, very precise measurement devices.
So I talked to some people, and I hate to do this to you, and I told you one
Please
of them.
do.
I told you one of them earlier before we started. I told some people, because people ask, "Who's your next guest?" This, and this, and so.
Oh, here we go. Okay, yeah, I know.
I told you the one. I told you the
it's
one.
a different one. Oh, okay.
Well, I have two.
Okay.
I told you one of them,
Mm-hmm.
and I'll ask you that one again. So they want to know if there's aliens, and I think we already know the answer.
If there's aliens, probably, almost certainly yes. The universe is too darn big, and it's too darn old, and the ingredients for life are too darn common for there not to be. It's just almost certain. The thing about it, though, that people don't, and you can't, I'm not blaming anyone for this, but the thing that's really hard to understand is the scale of things, how far away things are. So, okay, maybe we or some civilization figures out faster than light travel. If that's possible, maybe it works on paper, maybe it's just not feasible with actual technology that exists ever. So, if we're limited by the speed of light, the sun, okay, so the moon, we've been to the moon. That takes a couple, days, something to get through. That's 1 light second away. Sun, 8 minutes away. The nearest star system, Proxima Centauri to us, the nearest star, 4.5 years. We just went from 8 minutes to 4.5 years. How many minutes are in a year? And that's just the closest star. Okay? And Andromeda, that's like 20 some odd Milky Ways away from us, and 25, I'm sorry. And the Milky Way galaxy is 100,000 roughly light years across. So that's 250, times 25, 2.5 million light years. And that's the closest galaxy. And it's all empty space in between that. So, like, how are you going to traverse that? So people, can feel however they want to feel about the extraterrestrial deal, or, I've seen this, seen that, like, fine. But figure out how you're going to get from point A to point B after realizing how vast the distances actually are and how long it would take. And I'm talking about light, right? Only light can move that fast. If you have mass, you can't move that fast. That's the whole deal. Massless particles, which is what it should be called, the speed of massless particles, speed of light. But if you have mass, you can't go that fast. And so a civilization, people, like, that's, so you're multiplying the time even longer to get from point A to point B. So, like,
yeah, this Google says that Alpha Centauri is near star planetary system, 4.37 light years away, and it would take
that's a star system.
A human at our current technology, which is that 24,000 miles an hour, would take 6,000 years to get there.
Thank you.
That doesn't sound too bad compared to some of those other distances.
That's the closest one.
Yeah. What if there's beings there?
Could be.
Do we know for sure that there's not any beings around that sun?
Well, you would probably... Okay, so if it's a civilization that's relatively advanced, they'll be putting out radio waves, kind of like what we're doing right now. That's how, internet thing works. Mm-hmm. So you'd be able to see signs of them. Because okay, so remember, so radio waves, type of light, so it travels at the speed of light. So however long we've been putting out, radio waves, broadcasting ourselves, that's how big our radiosphere is what we call a radiosphere. So I don't know, when was the first radio put out? That many, like a century. Let's say a century. So our, like 100 light years.
1893.
93.
Yeah, so about a century.
More than a century now. So, I mean, it's 23 now, so 130 years.
Yeah.
So, and that's it. It's a little tiny radiosphere. We would have noticed them by now because they're only 4.5 years away. Our radiosphere is 130, right? So they're close enough that we would have seen something if they're... But that doesn't mean there isn't life, right? Of course, there could be little microbes or plants.
I think they found microorganisms. A probe found microorganisms in the atmosphere of Saturn, if I remember correctly.
That would have... I mean, that would be life on another planet, so I'm sure everyone would know. Maybe it's organic molecules, might be what you're thinking. That's more likely, I'd say. Because otherwise, we would have found aliens, and that everyone would know about that. If we found microbes, actual microbes in the atmosphere or anywhere outside the solar system.
I'll keep reading, but this headline says scientists find new signs of possible microbial life on Saturn moon.
Signs, and I'm betting it's Enceladus is the moon. ENC.
Enceladus is correct.
That's my favorite moon. So Enceladus is cool. It's cryovolcanic planet, which just means cold volcanoes. It's got geysers of water that it spits out. And those geysers we've known for a while, at least, few decades, that they have organic molecules in them. So those are the signs of life.
Yes, it says the authors made sure to clarify that their research does not in any way confirm the existence of extraterrestrial microbes on Enceladus. But
Yeah.
they did determine via mathematical models that the moon's relatively high concentration of methane detected by the Cassini spacecraft
Yep. Love
is
Cassini.
consistent with microbial hydrothermal vent activity on the bottom of the Earth's oceans.
And there are a few places like that. Like Europa is a big one of Jupiter's moons, which has more liquid water on it probably than all of Earth. Not on it, but in it.
Where's that at?
Europa? So it is, so Io Europa. So it's the second moon from Jupiter. So it's Jupiter, Saturn, so it's a little bit closer to us, right, than Enceladus would be. But it's got active oceans. It has liquid water, probably more liquid water than all of the oceans on Earth. And so that's another, maybe there's life there. We'll see. We have to dig through miles of ice to find out. But then there's Titan, which has the thickest atmosphere of any moon. That's another Saturnian one. It rains methane on Titan. So it's got a weather system, like it rains, it snows, rivers, valleys, but from methane instead of liquid water. So that's another spot, like, oh, hey, organic molecules. Maybe there's something there. So there are a few. And then Mars, obviously. There's ice on Mars. Maybe we'll find something there. So there are a lot of spots where there's signs of current or past life in the atmosphere of Venus, like the upper atmosphere. In the bottom, it's so hot you could cook a frozen pizza in a few minutes.
You said there's signs of what there?
Life.
What kind of life?
Any kind of life. Yeah. Life. DNA.
So
Stuff photosynthesizing.
speaking of this says there's hydrothermal vents like on the bottom of the Earth's ocean. So what you're saying is basically they've noticed, there's hydrothermal vents on Earth.
Mm-hmm.
Life is able to survive in like these crazy conditions because of the whatever thermal vents.
Mm-hmm.
And
Those get hot.
we're theorizing because we know that they're there. It's possible that there could be microbial life or extraterrestrial life there.
Uh-huh. Yeah, because life is sturdy and very tenacious. So, life can survive in very hostile environments. So that's why we throw out all these different potential areas: Europa, Enceladus, Titan, Mars. So,
By the way, this is kind of a little bit off subject, but I've been on a deep dive lately, like YouTube videos about like deep ocean exploration. And I was watching one of these hydrothermal vents, and they said that there's life surrounding certain hydrothermal vents that doesn't exist anywhere else,
right?
Because they've been there for however many, thousands and thousands of years, millions of years, and the life around it all has to fit into some sort of niche. Otherwise, it's not going to survive.
Mm-hmm.
So these animals or whatever start changing, evolving to fit that niche, and you might go from one hydrothermal vent to the next, and you'll never see the exact same iteration of the same animals. It might be the same species, but it doesn't.
Yeah.
It has like different attributes.
That's
wild.
That's the island effect. There was actually a section dedicated at the Harvard Museum I was studying at for a while to that same thing, that same phenomenon, but with islands. So like you'll see similar animals on like a big group of islands, but each island will have its own unique set of animals with their own niches, because everyone's an isolated environment, which allows evolution to sort of go wild with what's possible.
I think squirrels was one of them I seen on that.
Yeah.
There was a time where the island split, and
yes, and that's a great. That's one that you'll probably see in a biology textbook a whole lot. Definitely,
Yeah.
That's a good one. Mm-hmm.
Yeah. Mm-hmm. But on Venus, you mentioned something about there's evidence of past.
There might be so yeah. Let me clarify. Thank you. It's possible that life could exist in the upper atmosphere of Venus, because it's around like normal survivable Earth temperatures up there. So like airborne microbes, maybe.
Okay.
Maybe.
They haven't found anything yet.
No.
That you're aware of.
Well, we don't spend enough time or money on Venus.
Oh yeah.
Yeah.
There's a lot of
all the
stuff
money goes
out
to
there.
Mars. Yeah.
There's a lot of things.
Yeah, that's true. It's hard to pick, but I want to go to Venus more often. The only probe that we've ever put on the surface, I think Venera, I believe was the name, was sent by the Russians, the Soviets. So that's how long ago we've sent a probe. We've had some orbiters around Venus, but
On the surface of Venus, that probe was,
yeah. Mm-hmm.
what is the surface of what does the surface of Venus look like?
Hell.
Yeah.
So I mentioned it's really hot, right? So it's like 800 Fahrenheit, something like that. It rains sulfuric acid, and the atmosphere is so thick that standing on the surface of Venus would be kind of like standing under the ocean, at the bottom of the ocean.
With the pressures?
Yeah, same pressure. It sucks down there. It's bad. And there are active volcanoes that they've just verified for sure. Active volcanoes. So it's volcanic, it's acidic, it's dense, and it's hot. No fun. You don't want to go to the surface of Venus.
I think I've seen something where they said if you were going to live on Venus, you wouldn't live on Venus, you'd live in the atmosphere. You'd have floating houses in the atmosphere. There's like a perfect, like you said, in the north.
Yeah, like a Jetsons.
Is that the north? Would that be the north?
Oh, I think we were talking about the moon, maybe, or something like that. But it just up high, like the Jetsons.
Yeah.
Mm-hmm.
Yeah.
I was trying to remember, but yeah, there's a section in there about that.
But okay,
Exploration.
so the asterisk on everything that we're talking about right now is that we're talking about life as we know it and recognize it, right?
Mm-hmm.
So we're saying there's life possible in this place, there's life possible in this place, but that's all based on what we know life to be, right? There could be there could be other entities that can survive in different conditions or are made fundamentally of different things, or do we know for a fact that like you need certain, like you have to have carbon to have life? Like,
that's a great point. So my response to that is usually, so you're right. It's definitely hypothetical. We don't know if there could be some sort of like maybe a silicon-based life, for example. Can be completely AI, completely robotic. But that's still sort of within. When we're talking about life and the parameters for what life means, has to be able to replicate, has to be able to adapt to its environment. And DNA is just so perfectly suited for that task of replication and adaptation. The thing about it, too, is it's really set. It makes sense when you look at a periodic table why certain elements arrange themselves in certain ways. So, like, for example, why things are carbon-based. Well, carbon is the lightest of the elements that can bond with like four electrons at once, essentially. It's got 4 electrons in its outer valence shell, and that makes it very adaptable to be able to bond with a whole bunch of different things. Silicon is the same way. It's got 4 in its outer shell, but because it's bigger, it can't hold on to elements the same way. It can't hold on with the same amount of strength because things are farther away. And so that makes it more complicated and difficult for it to bond well with other atoms to make complex molecules that could then be used to maintain life, gather resources, like gather energy, like food, process them, be able to do more advanced functions like seeing, hearing, adapting to the environment. All that stuff is sort of predicated on 2 things. One, that carbon is light and very good at bonding with a bunch of different things. And 2, that water is so good at either being, it's water is an amazing molecule because it's polar and it can act as an acid or a base, and it has all these different properties. One big thing too is that water when it freezes, it doesn't get more dense like most things do. It expands, right? Ice floats, right? So it gets less dense, and that property actually can facilitate a lot of like protection as ice covers things, but there's liquid water underneath. All types of stuff, and because it's like a universal solvent, a lot of things can dissolve in water, which makes it a very good place for organic chemistry to take place. This was my research, by the way, when I was at Harvard for that summer project, was the origins of life. And I was looking at how the base nucleotides could bond together to form the very first like RNA, DNA in the early Earth. And it's just water is so good at allowing molecules to rearrange themselves and shift around that it's just hard to imagine other circumstances without that basic stuff, that water, that carbon for the scaffolding of life for the carbon, and then the
Yeah, so it's
you know.
it's deeper than just like
yeah.
oh yeah, like I definitely
There are
need
reasons for
water
it.
to drink, you know.
There's justification, yeah, but it's not talked about a lot, especially in those article you might read here or there, but it's important.
Yeah, that's true. The tagline is always like potential for life, but there's
Right.
absolutely no explanation. This article
Yeah.
that we were just looking at,
'Cause it's
microbial
clickbait.
life on Saturn, it's like 8 sentences. That's the whole article.
I hate those titles. I don't even watch them anymore.
Clickbait.
Yeah.
And videos are getting like that too. It's terrible. Like
if-
scientific videos, I mean, like.
Or if they have a good
You know.
one where they get me, I'm like, oh, really? Is there something there? I'll just go to the end of the video. I'm like, okay, and then they're
Yes.
like, well, we really don't know yet, or we're gonna keep searching. And I'm like, okay, didn't waste my time. Thank God.
And then it's like what the History Channel started doing with like those Bigfoot
Yeah.
TV shows.
But back to what you said
That's
earlier,
insane.
you're
Yeah.
right. We've only been searching. I mean, of course, hundreds of years ago, even back to Galileo, people had telescopes and doing that. I think about 800 years with telescopes or so, or no,
Yeah.
or more than that, like 1200 years. I think it was around 800 something. That
Oh, I just looked this up. Galileo was like 1600s, I want to say.
is it 1600?
It's pretty recent.
How long ago was Galileo? But nonetheless, you're right. Back to what you were saying, and even the about how long we've really been doing this as humans, and back to the space exploration, even with the space satellites and stuff like that. I mean, it's very short, and for I appreciate you coming on. I do, and answering these questions for us. And my apologies if we're asking the wrong questions.
Are no wrong questions,
Yeah.
especially with this stuff.
I mean, we're definitely
New frontier of human understanding.
Yeah, I mean, the second question I had from somebody was, ask them about flat Earth. So if that tells you anything about, where my level's at and where my friends' levels are at,
Galileo was born 1564, died 1642.
So,
Yeah, so you're right.
1600 was right in
Yeah.
half. That's how I remembered
So
it.
about
Okay.
Nailed it.
400 and something years,
Yeah.
400 years ish.
Not that long.
No.
People still thought that Earth was a perfect sphere, that none of the celestial bodies had any deformities like craters or sunspots. We've come a long way in a very short amount of time,
Yeah. Yeah, for
but it's
sure.
taken a long time to get there. About the flat Earth thing,
You don't
just
have to
ignore them.
You don't have to answer that one.
No, it's a good thing to bring up. This is my favorite. So there's a dozen plus different ways to, throw it out the window. And yet there's still people. I watched a convention of people one time of flat earthers meet in Texas. It was pretty disturbing. But one thing that I really like that I don't hear people talk about with disproving is say, okay, so you can buy, talking about Galileo, you can buy a telescope that was just as good as his for, like $20 something, like made out of cardboard, right, with the lenses and stuff. We used to make these for birthday parties with kids. And you can look up at Venus, which is the brightest object in the night sky after the sun, moon, of course. Real easy to find because its orbit is inside of the Earth's. It only comes up at dusk and dawn. So you won't see it in the middle of the night. Just sunrise, sunset, you'll be able to see Venus. Very bright. If you look at it with a basic telescope, you can see that it goes through phases, just like the moon goes through phases. So like there's a half Venus, quarter Venus. Do you guys know this?
I didn't know this. No.
Yes. So, and that's again because it's inside the orbit of Earth, so it goes around the sun, but we go around it. So there's sometimes.
You're going to say that's our shadow.
Yeah. Well, no.
No?
No, of course not, because we don't cast a shadow because we're outside of it.
Oh.
That's why Jupiter, for example, doesn't go through phases. It's outside of our orbit. We always see it fully lit. No matter where you are, you'll always see the outer planets fully lit.
Okay. So what's giving it the
So again, so if the sun is in the middle, right? What if Venus is on this side and we're on this side? We're on opposite sides. You can't see it, right? The sun's obscuring it.
Right.
But if it's over here, it's fully lit. Now over the other side, now it's like a new moon, right? Where the moon's completely dark, because you're seeing the shadow side. So trying to see if there's like a obvious light where there's shadows. But so if this is the shadow side, right? This is the nighttime side of Venus. Earth is here, right? And the sun's over here. This side's lit, daytime, nighttime. We're seeing no Venus. So crescent, quarter, full. So Venus goes through phases, and you can see that Venus is a sphere. So, you have to be able to explain why Venus goes through phases the way that it does without the Earth and all the star and all the planets being able to orbit around the sun, concentrically like that. And all of them are spheres, so how is the Earth different? I don't know. That's just one of my fun, more unique ways to talk about it. But it's just a waste of time, I feel like. I don't even bother talking to people who even think that. I don't even think I know people who think that.
Well, the more I've seen about that, the more I realize is that people will be like, well, the scientists can't prove this and this and that, but then they also can't prove their theories either. So it's not, but they don't back it with stuff.
And that's why I use the Venus one, is because that's something anyone can do. You buy a cheap telescope, go up and look at something that anyone can see with their naked eye, and so it's like just one basic observation you could do.
I think we talked about this before, Jeremiah. There's a documentary, a flat Earth documentary where
There's a bunch of them.
They tried this specific one. They were like, we're going to use scientific method to prove.
Oh, the lasers?
Yeah, where they set up the lasers and they say with the bend of the Earth or whatever, you shoot a laser from one point to another, and if the Earth is bending, it's not going to hit the other point because the Earth has, and they did it. And it proved that there was a curvature in the Earth, and then they were like, we must have done it wrong.
Not scientific.
I have a theory. This is my theory that I live by. I think that everybody who's heading one of those groups is banking on all the other people who follow the group. They're selling merch. They're selling books. They're selling, not CDs anymore, but whatever they're selling. And they know... They don't believe that stuff. That's my opinion. Yeah.
Wow, it almost sounds like a religion.
That's
did I go there?
Like a cult, for sure.
What's the difference between a religion and a cult besides age and size?
That's true. I heard somebody talking about that the other day. How you graduate from being a cult to becoming a sect, and you graduate from being a sect to being a religion.
Oh, that's
and
interesting.
Just
Yeah,
based on time.
Hierarchy of ideology.
Yeah.
Yeah, most astrophysicists.
That's chapter 8, by the way.
Is it chapter 8?
Culture.
Cults. Oh.
Culture. And a
Culture?
section on it includes religion. There's some, basic culture stuff, art. It's like some fun stuff, and then drugs. Just because I was researching them at the time, and my parents have background in drug and alcohol, like law enforcement stuff, but religion also. So culture. Anyway, sorry to interrupt.
No, I know that a lot of scientists, a lot of astrophysicists, a lot of people in those fields, they don't believe in religion because they're looking out there, and they don't see God. But is it possible there's a God?
Oh, well, that's the unanswerable question, right? Kind of. Yeah. Everyone has their answer, and everyone's correct. So I don't know. We can talk about this if you want, but I went through phases where I grew up Baptist, or my dad would read the Bible to me before bedtime every night, and then I get older and I sort of, become more scientific, and then go through like an atheistic phase. But then I go through and I study, all the other religions. So through like the whole process, I studied the Abrahamic ones, so Judaism, Christianity, Islam. But then, after graduating college, I finally had enough time to go through and study more. So I, learned a little bit more about Buddhism and Hinduism. And after a while, they sort of start blending together a little bit more. So I guess I'll just say this, and then I don't have to say too much more on the topic, unless you want me to. But, different people use different words for the same thing. Atheist says the universe, the Christian says God, the Muslim says Allah, the Hindu says Brahman, You know, I think they're all talking about the same thing at the end of the day. But my way of thinking about it, at least to summarize, so the theist says that when you pray, you're talking to God. The atheist says that when you pray, you're talking to yourself, right? And then the Hindu says that they're both right. And I just leave it at that.
So with the organized chaos of the universe,
yes,
could that have been designed?
What do you mean designed?
I mean, you look at everything, like just
how it all fits together.
How it all fits together, how it all reacts to each other, how it all supports each other, and then there is some chaos out there that's just destruction too. I mean, then you're wondering, what does that support? But maybe it has a purpose.
Well, they go together, right? Just like up goes with down, construction goes with destruction, so to speak. But in terms of like design, well, I mean, I guess, it depends on your phraseology. I
mean, if you
for every one universe that does work out and seems to fit in with all the pieces together, what if there are a trillion other ones with different laws of physics that didn't work out, that just fizzled out after, I don't know, 1 million years, 2 trillion years, 4 trillion, or some that last longer than ours, maybe.
Yeah, what if? Yeah.
I don't know.
As my kids my kids like to say, they said, if the universe is infinite and everything is infinite, is there an infinite number of realities and an infinite number of us and an infinite number of situations? Right now I'm doing something.
There are different levels of infinity too, which really makes your head hurt. There's a YouTube video on it. It explains a TED Ed video, so like an educational one, but a TEDx video about different levels of infinity. There's some other PBS ones that I've watched. That's high level. But yeah, there are different levels of infinity.
Yeah, and I talked to my kids about that.
And different types of multiverses. There's one like where there's infinite numbers of us and it just repeats. There's one where it diverges like a tree. Every decision you make, I go left, the other me goes right. So there's different types of multiverses too that you could think of.
But there's no evidence of that
No,
yet.
Nothing
yet.
Other than observations made in quantum mechanics, again, about like superposition. You might have heard things about like Schrodinger's cat being both alive and dead simultaneously before you observe it. That's what the idea of superposition, at least, where a particle seems to be in two states at once, and it doesn't choose its state until it's observed. Stuff like that sort of leads into these ideas of multiverses and alternate realities, stuff like that. But that's hypothetical. If people say, oh, it's theoretical that there's a multiverse or whatever, it's hypothetical more than that, because not even some of the math works out. It's just ideas gleamed from some of the mathematics. Some of it's more reputable, so there's like degrees too.
Has anybody ever tried to repeat that?
Repeat what?
That study with the cat. I seen that on YouTube. It was an interesting video.
I mean, I'm sure there are probably some Russians or Chinese folks somewhere out there who would torture a cat like that, but I don't know.
Yeah, we don't do that kind of stuff.
Because do you know the experiment, the Schrodinger's cat experiment?
Yeah, I seen a YouTube video on it.
Yeah, so the idea is you put gas in it, and it's simultaneously alive and dead until you open the box.
Right, they killed the cat.
Yeah, but there's no way of observing. That's the idea, is like you have to observe in order to know what happened. It's more of the principle of things. So it's not even an experiment. It's more of they call it a Gedanke, like a thought experiment in German. Gedanke.
It's like existential kind of question.
Yeah, and that kind of bleeds into philosophy a little bit more. As a hidden Gedanke is sort of like I think of it like a Japanese koan. It's like a question that doesn't have an answer sort of thing. So it's a thought experiment that is more... The process of answering the question is more enlightening than finding an answer in of itself type thing. And that's kind of where I think a lot of these quantum mechanics and multiverse things sort of go. It's the exercise of thinking through them that's enriching, I think.
Yeah, because
not sort of the ramifications as much.
I didn't understand it. That's why I was asking if they ever tried to repeat it, because I didn't...
It's not a real experiment, really, that you should or can do. Not just ethically, but just like it's not possible to do it because, again, we're talking quantum scale, which does not seem to apply at all to everyday scale that we're used to. So it's not possible to do a quantum experiment with anything that you can see with your eyes. A cat, a fish, a rock. It's just an example for the principle of superposition. It's not actually a scientific experiment.
Yes,
if that makes sense.
It's way over my head, man.
That's okay. It's quantum. It's a kind of the idea, like.
Yeah.
And that was what they told us at the beginning of our class. It was like, you're not supposed to understand this.
But so this is the idea. No,
And that's okay.
I might be wrong on this, but quantum computers, right, are named so because they supposedly have the computing power to perform quantum experiments?
Yes. And again, I'm not an expert on especially computing. I'm not great at computer software engineering, but I can give you the basic surmise what the difference is. So normal computers use bits, ones, zeros, 1 or 0, 1 or 0. Quantum computers use qubits, which would essentially be a particle that's in that superposition that we talked about, where it's 1 and 0. 1 and 0. So it's like 4 possible states because, so if you have 2 bits, that's 1 or 0, so that's 4 possibilities, and you just double that for qubits, essentially, because it's 1 and 0, 1 and 0, and that's like 4 possibilities.
So it's like a multiplication of the computing power of the thing.
That's the idea. Quantum computer work good, lot better than normal computer.
Lots of good, great stuff.
Do good computing. Do good computer. Yes.
Man,
my brain hurts.
Good.
I don't know about you, Michael.
I don't know.
I feel like I don't know anything.
Yeah, me too. But I keep asking questions. Eventually,
For
I'll
sure.
figure some of it out, I guess.
Well, we could switch topics if you like. Something more grounded, like working out. Like I'm really admiring this gym because I get to look.
You
at
like
it.
that?
Yeah, I loved it. So I didn't want to go into too much detail because I know we want to talk more here. But so my father is a world-class powerlifter. It's kind of funny because he's shorter than I am, but he's like jacked. So like I think his max bench was like 450, max squat was like 400, and then max squat was like 600. And again, he's like shorter than me, so it's like that big powerlifter guy. And he got me into the gym. He was my trainer growing up. I train mostly for martial arts, not for like bulking up or lifting heavy things, picking them up and setting them back down. But I love going to the gym. I do. When I did, I'll start back up in August probably, but I'd go 6 days a week.
That's good,
to
man.
lift.
That's good.
It's fun.
Now he's talking my language. Now I can chime in.
I told you, I'm diverse. I can talk about a few things.
Although I've been slacking. I've been so busy that I haven't been really doing much, but been busy. I hope to get back into it. I definitely have the gym for it.
Now, you're remodeling here. Are you going to put a sauna or a steam room? Because that would be cool.
Yeah. So for other health things and the benefits from that stuff, we're going to put that in the new section. Yep.
Cool.
Yep.
Nice.
Yeah.
That's my favorite part.
Yeah, absolutely.
Sauna.
Little cold plunge outside.
Yeah, some cryotherapy is great.
Yep.
That diversity. It's better than just taking a cold shower.
Cold shower doesn't get cold enough.
Yeah. Yeah, exactly.
Yeah.
Right.
It'll get to 55, 60 degrees depending on the time of year because it comes from the ground. Whatever the ground temperature is, it's basically what it is.
Mm-hmm.
So yeah, it's better than nothing, but it's
right.
It's not
Not
the best.
controlled.
No,
Yeah.
no,
Yeah,
not controlled. So you also do tutoring as well.
Yes, sir.
So you tutor people on what?
Basically, so what I say is I'll tutor anything that I've taken and passed before. So that's like all the way up to my degree, all the physics and math classes. But then also like, cause I took advanced high school classes, which was how I was able to graduate college year or two, cause it takes some people 5 years to get my degree. I was able to save that time because I took advanced high school classes. So, every now and then I'll take on an economics student, general history student, obviously like math and science. Most of my students are high school, college. I'd say like 2/3 be physics, math, and then like half of that maybe for chemistry, and then the other sixth would be like miscellaneous random class, and that's like all ages. So I like to have like 1 or 2 elementary school kids per semester, and just do something basic like arithmetic or just read books together. That's just to take some of the pressure off, and then from the more advanced students. But like I just got one today that she's I think in her early mid 40s, something like that, going back to school, getting a new degree, and I'm just helping her with algebra. Had another lady a few years ago who was probably like I want to say late 50s, early 60s. She was getting her real estate license, so she needed help with real estate math, which is just like it's again high school stuff, but it's those percentages and interest and stuff like that. So mostly math and science, mostly physics, but with a healthy spread to keep things diverse. Yeah, so I've been doing that for about 6 years now, since 2018. Fully self-employed, no W-2 income, all 1099, which I'm very grateful for.
So do you hire other tutors as well, and you?
No, because I would if I wanted to expand it to a larger business, but I don't. It's just like basic income to invest into other larger projects, which will act as more of a long-term like retirement plan, other online businesses, and then retirement account through the market, and then books. So I've got, I'd say 4 or 5 different streams of income, and so tutoring is just like the thing that I do during the day, like pay per hour, essentially.
Yeah, of course.
Yeah.
Do you have if people wanted to look for you, and if they wanted some tutoring, do you have openings, or do you just have to see when you have openings?
Yeah. People can reach out anytime. I'll usually work I'll usually work with a caseload of about 40-ish students per semester is usually how it works out. Sometimes, and of course, it varies by student. Sometimes I meet with them once a week, sometimes twice a week, sometimes once a month. Sometimes it's once and then they're good from then on. So it varies. So it adds up to about 40, but it'll be like, I work 6 days a week. Was it Sunday through Friday? And so that adds up to like, 40 to 50 hours a week during the school year. So I've got openings. Yeah. I do it full time.
Where would somebody find you if they wanted to maybe look at getting some help with some tutoring?
Yeah, so if anyone just looks up Ariel Manzanares-Scisney, just my name, that should connect you to all my social media, and I have all my contact info, hopefully like on multiple different places. So there are like a dozen different ways to find me if you just know my name. Should be pretty simple, and then message me directly through social media or my associated phone numbers. I have specific phone numbers for planetarium stuff, for tutoring, and then my personal lines. So,
and we'll link all of that stuff.
Thank you.
Websites, social media stuff in the description for the video and the podcast.
Perfect.
What help? So you're trying to get the Lakewood Planetarium. Actually, it's called the Robert H. Johnson Planetarium, right?
Yeah, he was the superintendent when it was built in 1963, so it's named after him. But yeah, it belongs to Jefferson County Public Schools currently.
What is there anything that people can do to help you with that? Or is there?
Yes.
What?
So I would start with checking out our website, rhjplanetarium.org. That's important. It's .org. And like I said earlier, I'll be finalizing all the legal stuff for the 501c3, and so I'll be advertising those a lot more. We can accept donations in a more tax-friendly way that keeps the IRS happy, and we'll be using those donations. Those are all set aside in a separate account, so they don't get mixed in or used any other way. And we're currently going to be saving up for that new planetarium software, which will, I think, be in the ballpark of like 6,000 or 7,000, and we're more than halfway there. We've got like 4.5 like for 4,500 raised up right now. So if you go to the website, you'll see info to learn more. You can donate if you like to the GoFundMe as well. And that's probably the number one way. And you can get a free book too if you donate $20 or more, if you like. And they'll be personally signed by me as well.
Yeah, I was just going to ask you, where can someone go find the book? But if they're going to find it and buy it anyways, they might as well just donate to the Planetarium.
And when you do that as well, it adds, because GoFundMe, in addition to, you know, obviously being a way of collecting funds, is in a way what it's escaping when you get a bunch of lists of names, not survey,
like a guest book, a ledger.
No, like
Donors?
No, this is when you have like a political thing, you have people sign
a petition.
Petition. Thank you. Got it. Petition.
There we go.
So GoFundMe also acts as a petition. So even if you donate, say $1, if you add your testimony, we can share that with other people and put it on the website. And that goes a much longer way than any dollar amount could, just adding that testimony. And so we can go to the district and say, hey, this many people want the planetarium reopened in our community, and that adds more leverage to the whole project. So $20 is just so that way we stay in the black and actually, don't lose money by printing and mailing a book to someone. So that's why the cap exists. But just adding, your name, that's the most powerful thing, I would say, to that GoFundMe, because it acts as a petition in addition to just a fundraiser.
Yeah, when are you guys hoping to have that open? What's the goal?
My goal would be fall of 2024. So the budget for Jefferson County ends in June, and they've just started up the new one in July, and that's kind of the fiscal cycle. And so right now our goal is to, like I said, use funds for outreach events, promotional stuff, advertisements online like Facebook ads, etc., Google ads, in order to galvanize the county into contributing some of the larger expenditures, like the roof needs to be replaced, the electricity needs to be looked at, stuff like that, like maintenance repairs. If they own the building, I feel like they should handle it, and they have their own preferred vendors, because I've tried to get people to come in, people have volunteered to come in and fix up the place, but the district's like, no, we've got people for that, you can't go there. So I'm like, okay, well then take care of it. And so part of it is just getting the building on the district's budget. There are funds, like you can look up the actual funds for Jeffco every year. They'll put out the budget publicly, and I've read through the last 2 years, and I think I found, enough funds to manage like half, like $500,000 to $1 million worth of expenditures just on the side that they could use that they've already allocated for building maintenance and expenditures. So
Nice. Nice. That's great, man. I want to go there when it opens.
You are more than welcome. I'll take you through a tour of the universe. Or
I want to go as far as you can take me.
Sure.
All the way to the edge.
I'll take you farther, in fact, because you can leave the edge. You can just fly out, because it's just simulation.
We want to see the aliens.
I'll do a rendering of it. We have movies with aliens. A lot of them are kids movies, but we have movies with aliens in them.
So if you're flying and I say, stop, take a left right here. I think I seen something over there.
Easy.
Yeah? Easy?
Yeah.
And I'll
Simple.
be like, oh, no, it's just
another star.
It's just a star.
Most of them are going to be just dots that are placed there, because you have to look at each individual star, right, to think like, okay, how many planets are orbiting around it, and you have to do that with trillions of those things. So, but more and more data is coming in all the time.
Yeah, and that's not the only thing you guys are going to do there either. You're going to do classes and education.
Yep. Classes, and teachers will be able to come in and write their own programs for students. Like, say you want to do a Shakespearean play for your English class, we can put up the backdrop and do that. We've had, live concerts. Like I said, film festivals. People love the laser shows and planetariums. Those are classic. But you have more advanced ones, like with the special effects, like if you remember your old iTunes visualizer, like those things that match up with the music and sync up with it. we've got stuff like that too for.
I've never been to a planetarium. Did I say that earlier?
We'll have to get you. I think Fisk still lets me
Never.
print off tickets, so we'll see if we can get you guys to the one in Boulder. You'll have a better idea of what I'm talking about.
I've been to the Gates Planetarium. Where you just kind of sit back and watch a pre-planned movie. And but the thing is it's like you don't. It's cool, but you can't go all the time because it's like they're just playing a video, and a lot of times it's.
And you have to get into the museum first.
Yeah, that's true. It's a admission upon admission.
Admission upon admission. That's the thing. It was the same thing at the Boulder, or the Boston Museum. You get into the Boston Museum of Science first, and then into the Charles Hayden Planetarium. Although I think you might be able to bypass. I think they had to say bypass. So Denver is actually worse than Boston in that regard, and they have to go through the whole museum to get to the planetarium.
Come on, Denver.
Tisk. But that's okay. It's still cool. I love the black. That's where I first saw the black hole show, and that changed my world. That revolutionized my life. That movie did. The one narrated by Liam Neeson.
I didn't see that one. Sounds sweet though. Sounds scary.
It's a classic. That's our primetime movie that we would play on Friday nights for folks. Always packed out shows. Probably still does.
Liam Neeson narrates everything. I feel like he narrates his own movies even.
He's got one of those voices, you know.
Him and Benedict Cumberbatch. Him too. He narrates the Sun movie that we have in the planetarium.
Oh, does he?
By the Sun. And a couple other ones, I think. But he's done documentaries and stuff.
Well, man, I don't know about you, Mike, but I need a nap after this. My brain is like
time to sit and meditate. Well, you know where I'm at. If you ever want me to come back and chat more, I'd be happy to.
Oh, absolutely. You're my guy. If anything goes on in space where there's anything that I have questions about, we're calling you.
Yeah, if I'm laying in bed just thinking about life in space and I have questions, I'm gonna call you.
Life, the universe, and everything. That's about. Well, I mean, start with chapter 1. Oh, also, I should mention about the book too. It's written in such a way that you don't have to read it from front to back. You can read it passage-wise. So you can open up any random page or any random section. You can kind of go through it however you like in whatever order you want. So the chapters are not in a specific order other than how it made sense in my mind to go through things.
Because the chapters are different topics.
Yeah, so for chapter 1, that's the whole history of the universe. Chapter 2 is, so that's when are we kind of? Chapter 2 is who are you is the title. And that's based on neuroscience and then genetics. And so the first 3 chapters are very math and science heavy. So they're very technical and some people will have a hard time getting through them probably unintentionally. I tried to make it readable. Then that's section 1. Section 2 is about it's called Pillars of Knowledge, but it's about the school subjects that we all go through, the English, the math, the history, and it's about how are they useful and applicable to everyday life? Because that's a question we all have as students, right? Why am I learning this? Why do I need to know this? How is this going to be helpful for me in the future? Well, that was my best attempt to answer that question for those various subjects, how they connect with each other, how they enrich your life, how they can be used in a productive way to make you better at your job or your career or whatever. And then I go into those career stuff in the final section. And I just talk about things like industry and agriculture and different jobs, entertainment, martial arts, obviously, for a little while, and music, art, all various different things and how those are sort of blossomed from the most fundamental things in the universe. So, should be fun. And it's very conversational. It should be you're just chatting with me when you're reading the book. That's the idea.
Yeah, I'm going to have to read it, man. Thank you for the book.
You're very welcome. Absolutely.
I'll give it to you when I'm done with it, Michael. I'll give it to you when I'm done with it.
Yeah, I'll take the seconds.
You can have it first. I don't care.
I'll just bring another one. It's fine.
He's keep you guys from fighting.
I'll read it, but then we'll have you back and you can explain everything to us that we didn't understand.
Yeah, and you'll probably have more questions okay, why'd you write this? Why'd you say it this way? Do you still think this?
Yeah, I wish I would have read it before we sat down.
Oh, no. It's
my apologies.
No, don't worry
I didn't have it.
I am humbled that you have it in the first place.
I appreciate it, man.
Of course.
Well, thank you, Ariel. Do you have anything else, Michael?
No, I don't think so. I mean, I'm still thinking about the things we talked about before. So, no, thank you so much. This was awesome.
Of course.
Very informative.
Yeah.
Absolutely.
It's great to be able to sit down and just like shoot questions at somebody and then have them answer or try and answer them. You know?
Absolutely. And this was a lot of fun for me too, because I don't get a lot of chance to talk about like the more fun out there stuff, because I'm always talking with students about like this physics problem. You do all these, it's all
We're
equations
not
and
working
stuff
within
like
the
that.
constraints of a textbook.
Exactly. I'm the textbook. No. Well, I do say that to students sometimes. If on the rare occasion where there are some clients where the parents hire me to like, teach their kid from scratch, or like, just like a Aristotle type thing with Alexander the Great. You just like sit there and mentor them and teach them life. I'll just give them this book usually. That doesn't happen too often, but that's what I'll use it for. Like, here, that's your textbook. That's your life lesson. So.
Well, thank you, Ariel.
You're very welcome.
Appreciate it.
All right.
We'll have you back again soon, I'm sure.
Looking forward to it.
All right,
Thanks,
Ariel.
guys.
Thank you.
All right. Yeah. Ariel. R-E-L.
Ariel.
R-E-L. Like
Ariel.
R-E-L.
You got it. You got it.
Ariel.